Hello and welcome to another Ginger Mathematician video. So today we're going to go through all of permutations and combinations for the A-Level Maths 9709 paper 5. Often a topic that students find tricky, so I'm going to go through this nice and carefully to make sure you're getting all those marks on the paper 5 exam. Now, the two words we really need to look out for in any permutations combinations question are arrangements, so this word here, and selections. So when we talk about arrangements, we are talking about permutations. And what does that mean in, say, normal English? And that means that order matters. So what do I mean by order matters? Well, we have A and B. Well, A and B and B and A, they are two permutations. However, when we come to selections, and these are the words they use in the exams, we're then talking about combinations. And again, what does that mean in normal English? Well, that means that order doesn't matter. So just a very basic example here. If we have AB and BA, then AB is one combination, but AB and BA are two permutations. Making sure we remember that is very important. When we talk about selections, we're generally dealing with binomial coefficients, things like 5C2, for example, whereas arrangements, we generally take this slot filling approach that I'll go through in this particular video. Right, let's get straight into exam questions. This is the best way to make sure we can do them in the real exam. So Richard has 3 blue candles, 2 red candles, and 6 green. The candles are identical. This is important. Apart from their colours, the only way you can recognize them. And he arranges the 11 candles in a line. And we're looking for the number of different arrangements. Keyword here, so we're looking for permutations of the 11 candles if there is a red candle at each end. So I tend to do this slot filling approach. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have my 11 candles, my slots, and we need to have a red at each end. So we put an R in here and an R in here. That means we have in the middle here, the ones that we don't know about, 9 different slots, which is important. So to find the arrangements, so we'll use arrangement equals, well, we have 9 slots, so we're going to write 9 factorial, as in we can have 9 different ones in here, 8 different ones in here, 7 different ones in here, and you see this idea, 4, 3, 2, 1, and then to work out the different arrangements here, we multiply these numbers together, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now generally we shorten that down using this factorial notation. So notice if I had 3 factorial, this is 3 times 2 times 1. If I had 5 factorial, this is then 5 times 4 times 3 times 2 times 1. I will show you in a moment exactly where on the calculator we do this. However, we have to be slightly careful with this because we have the red candles are already accounted for, but we have the blue candles here and we have the green candles here. And notice if I swap over a green candle, I can't actually tell if that's a different arrangement. The way we deal with this is that we have 3 blue candles, so we need to divide by 3 factorial. This is important. And we have 6 green candles, so we put 6 factorial at the bottom. So again, go through how we got this. We have 9 slots that we don't know about. So we have 9 factorial, and then we divide through by the repetitions that we have. So we have 3 blue candles, so 3 factorial at the bottom, and then 6 green candles, 6 factorial at the bottom. So now I'm going to go to my calculator and show you how you type this in. Okay, so I'm sure you've got a calculator similar to this. Again, this is a standard Classio class quiz here. So what we're going to do is type this in. So we've got our fraction button, then we go to 9, and then we find our factorial button. On this calculator, it's the shift and this key here. That gives you this exclamation mark. Don't say that to a maths teacher. And then we have 3 shift here, and then we have 6 shift here. Then we just press the equals button, and we get syntax error. So if I go back, what did we do wrong here? We need to make sure that we have a times in the middle. Now we get our final answer here of 84. So we pop that in and we have 84 different arrangements. You have to be very careful with language in these stats papers. Now on to part B. Again, generally part A is a sort of easy 1-2 mark question, and then part B or even part C will then be more like a 4-mark style question. And we need to find the number of different arrangements of the 11 candles if all the blue candles are together. So I'm going to underline that. And this is important, the red candles are not together. Now, as soon as I see a not in this kind of question, I tend to take a slightly different approach, maybe to some teachers. So the first thing I want to do here is I want to work out the arrangements of blue candles together, ignoring the red for the time being. So together. And then I want to work out the arrangements, and you'll see right at the end why we're doing this. Arrangements of blue together and red together. So I'm kind of ignoring the not for the time being, but we'll kind of work backwards to work out what that is. So if I want the arrangements of the blue together, so we have our slots 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we want the blues together. So we have 3 blue candles. So let me just put it randomly. So B, B, B. The key technique here is to consider like there's a rope around these blue candles, and they basically count now as one big slot. So notice one big line over the top. So how many slots do we actually have now? So we have 1, 2, 3, 4, 5, 6. One big slot here, 7, 8, 9. So we actually have 9 choices in terms of what we put in here. So we're going to have 9 factorial, but then we need to divide through the repetitions. So we've dealt with the blue, but we've still got 2 red and 6 green. So we need to divide through, just like in the previous question, by 2 factorial and 6 factorial at the bottom. So this calculation here gives us the arrangement of all the blues together. Now we have a similar kind of question for arrangements of blue together and red together. So if I do my slots, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have the blues together. Let's put it over here, doesn't really matter. That's going to become one big slot like we did before. And the reds together. So we've got how many reds here? 2 reds. So we put the 2 reds together and consider that as one big slot. So let's see how many slots we have now. We have 1, 2, 3, 4, 5, 6, 7, 8 slots. So this is going to be then 8 factorial, but we need to divide through by the repetitions. We've done the blue and red, so the only ones left here are green, so we need to divide through by 6 factorial. Now, how does that actually help us answer the question? Well, we use this idea of probabilities essentially adding up to 1. It's kind of an idea of this. So if we have blue together, so I'll put blue T, that's going to be equal to blue together and red together and blue together and red not together. Because notice blue together, again you've got all the other conditions, is equal to blue together, red together, and blue together, not red together. Because either red is together or red is not together. So these two have to add up to the total that we have just blue together without any other conditions. Okay, so what does that mean then? So blue together is 9 factorial over 2 factorial, 6 factorial. Blue together, red together, we just worked out, so that's 8 factorial over 6 factorial. And this, blue together, red not together, is what we're actually looking for in the question. So let's just say plus x. So actually we have now an equation that we can actually solve. So to work out x on its own, what's the opposite of adding 8 factorial over 6 factorial? Well, we minus it from both sides. So this becomes x factorial is equal to 9 factorial over 2 factorial, 6 factorial, minus 8 factorial over 6 factorial. Again, we plug that into the calculator. Again, I give you a chance to do that at home, and that will give us 196 arrangements for our 4 marks. Key thing to keep in mind, whenever you've got these not questions, my general strategy is to work out when they are together and then find the differences between them. What you'll find sometimes with these exam questions is that you can actually use part A to help you with part B. Not in this case, but sometimes that's quite nice. You can just use what you've got part A, do a little bit of calculation here, and then work out part B. Okay, so you can see the mark scheme here. I generally take this alternative approach at the bottom to get to my 196. Okay, on to the next question. Again, if you're finding this really useful and you want more paper 5 content, which I'm currently working on at the moment, then please do like and subscribe. It's a great way of spreading this to as many A-level students as possible and helping them out with their upcoming exams. Okay, next question here. So 6A, find the total number of different arrangements. Again, I'm looking out for that. So we're going to use the permutations here of the 11 letters in the word caterpillar. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this is just going to be 11 factorial. However, what repetitions of letters do we have? So let's have a look carefully here. We've got 2 A's. So I'm going to write this down for later on anyway. I've got 2 L's. So I'm going to write that down for later. I've got 2 R's. So here and here. Do I have anything else? We've got a C, a T, an E, a P, an I. Okay, everything else is fine. So we divide through by the repetitions. So we have 2 factorial for 2 A's, 2 factorial for 2 L's, 2 factorial for 2 R's. So again, let's go to the calculator. Let's practice a bit at working this out. Okay, so let's work it out. So we have fraction button, get 11 factorial, shift, and this button here. And then we're going to divide by 2 factorial, which is actually just equal to 2. 2 times 1 is 2. But let's just do it properly here. Times 2 factorial times 2. You might be surprised how big the answer is going to be here, by the way. And it is a massive number here, 4,989,600. So 8,9,600. I know stats tests can be quite difficult compared to some of the other modules, but this gives you 4%. Just by doing this, you just get 4% of the exam just by doing this fairly straightforward procedure here. Now we're looking for the total number of different arrangements, again keyword, of the 11 letters in the word caterpillar, in which there is an R at beginning and end, and the 2 A's are not together. Okay, R at beginning, R at end, 2 A's are not together. So we're going to use a similar technique as before. So let's just do the total where the R is at beginning and end. Okay, so we have 11 slots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have an R at the beginning and an R at the end. So that gives us 9 slots in the middle. So that's going to be 9 factorial. And now we need to think of the repetitions. That's important. So if we go back here, we've dealt with the R's. So we just have the repetitions of the A's and the L's. So we're going to divide by 2 factorial and 2 factorial. So that's fine. Now let's look at the total arrangements where we have R begin and end. And we have the A's are together. So the opposite of what's in the question. Okay, so we do our slots here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have the R's beginning and end. We have the A's together. So again, imagine this is now 1 slot because they're together. So how many slots do we have now? 1, 2, 3, 5, 6, 7, 8. So this is going to become then 8 factorial. And we've dealt with the R's, we've dealt with the A's, so we're only left with L's as repetitions. So we have 8 factorial, and then we have 2 factorial at the bottom. And now we do the similar process to what we did before. So the total with R begin and end is equal to total with A's together plus total A's not together. Because either the A's can be together or the A's cannot be together. There's no other possibility I haven't considered. So total R's, which just begin and end, is what we had. So 9 factorial over 2 factorial, 2 factorial. Total A's together, we just worked out 8 factorial over 2 factorial. And this is what we're actually working out. So we just call that an X. And now we just rearrange our equation. So then we get X is equal to 9 factorial over 2 factorial, 2 factorial, minus 8 factorial over 2 factorial. And if we work this out, then we put the answer just up here. That's going to give us then 70,560 for our 4 marks. Once you get into the kind of pattern of these kinds of questions on paper 5, they do become easier and easier. Again, key thing, as soon as we see not here, then we consider when they're together and then work backwards. Now here we have a slightly different part of question C here, and now we're doing the total number of different selections. That means we're going to be working with combinations, so that's important. So, selections of 6 letters from the 11 letters of the word caterpillar that contains both R's and at least one A and at least one L. So what we're going to do is write down all the selections possible, following those, thinking about the R's, the A's and the L's, and the other letters then we'll deal with later on. So let's write down all the different situations. So we have R and R. So we're going to have R and R in each of our different situations. And now let's think of at least one A and at least one L. Remember, there are 2 of each here. So there's 2 of these and 2 of these. So we'll start with A and L, so just 1 of each. That means we still need to put in 2 extra letters. Then we have 1 A and 2 L's, so 1 extra letter, other way round, so 2 A's and 1 L, 1 extra letter, and then both A's and both L's. So that gives us all 6 letters here. So here we only have one possibility, 2 R's, 2 A's, 2 L's. If we take the top one here, we've done 2 R's, 1 A and L. So we've considered basically R's, A's and L's. They are done. So what other letters are we left with here? So we have a C, we have a T, we have an E, we have a P, and we have an I. So we have 5 letters, 1, 2, 3, 4, 5. So to work out what goes in here, this is where the binomial coefficient's in. We have 5 letters possible that we can use. We've already considered all the situations with R's, A's, and L's, and we want to put 2 in. So 5, choose 2. We want to choose 2 letters to go in here from a selection of 5. Here we have 5 letters from 5 letters to choose from, and we want to choose 1. And here 5, choose 1. So we've got one situation here. 5 choose 1 is just 5. 5 choose 1, again, you can check on your calculator, is 5. If you're not sure about 5 choose 2, let me show you how we do this on the calculator. Okay, so here we're going to use this NCR button at the bottom. I want to work out 5 choose 2, so choosing 2 letters from a selection of 5. So all we do here is just type in 5, shift and divide 2, press equals, and we'll get our answer of 10. So if you ever want to work these out, again, you have a calculator in the exam. It's good to know, like 5 choose 1 is 5. If you didn't know that, then again, you can use your calculator. So we have 10 possibilities here, 5 here, 5 here, 1 here. So we just add all these numbers together, and then that gives us 10 plus 5 plus 5 plus 1, and that's equal to 21 selections here for the 4 marks for this question. Right, so you can have a look through the mark scheme. Again, this is 6A and 6B. Again, I've taken this method 2 at the bottom, and then 6C here. Again, we've got a couple of choices. I've taken method 1. I think that's the most intuitive. And again, under the pressure of an exam, you want a method that's intuitive and makes kind of logical sense that you can work your way through. Okay, and on to question 5. So we have a group of 12 people consisting of 3 boys, 4 girls, and 5 adults. And how many ways can a team, this is always an important word to look out for, of 5 people be chosen, also important, from the group if exactly 1 adult is included? So as soon as I see words like chosen or a team, then I know it's going to be a combination question. And that means then that order doesn't matter. So generally we're going to be using binomial coefficients, which we'll explain in a moment. So we want exactly 1 adult. So we have 5 adults and we want to choose 1 adult. That's going to be 5 choose 1. And then the rest of our team here of 5 people, so we have 4 people remaining, will be chosen from these 4 boys and 3 girls. So we multiply by 7, choose 4, because we want to choose 4 people for the team out of 7 people left over. So let's go to my calculator and work this out. So we've got the calculator here. So we're going to be using this NCR button at the bottom. The way we use this, we have 5 and press the shift button. That's C1 and then multiplied by 7, shift C4 to make sure you know how to use the C and P on your calculator, and that then gives us 175, which we can write in for our 2 marks. On to part B, is how many ways can a team of 5 people, so still combinations, be chosen from the group if the team includes at least, this is important, 2 boys and at least 1 girl. Now remember, we have 3 boys to choose from and we have 4 girls to choose from as well. So now we need to write down all the different, we've got 5 adults as well, all the different combinations. So at least 2 boys. So I'm going to start with boy, boy. And now we go through the other parts here. Well, we could have 3 girls. That's perfectly fine. We could have boy, boy, and then 2 girls and an adult. Or we could have boy, boy, 1 girl and 2 adults. Notice we've got 5 adults to choose from, so that's perfectly fine. We could have at least 2 boys. Well, there are actually 3 boys, so we could have 3 boys and 2 girls. Or we could have 3 boys, 1 girl, and 1 adult. That fits the conditions that we have at the top. Once we've worked this out, then we can just work out the different combinations. So for here, we've got 2 boys, so we're doing 3 choose 2. So we're choosing 2 boys from a selection of 3 and then multiplied by 4 choose 3. We have 4 girls. We want to choose from a selection of 4 to get 3 girls. And now we do the same idea here. So again, we've got 3 choose 2. We have 4 choose 2. So we've got 4 girls choosing 2 girls from that. And then we have 5 choose 1. Again, we just go through this nice and logically. So 3 choose 2. And then we have 4 choose 1 and 5 choose 2. And now here we've got 3 boys, so we have 3 choose 3, basically 1 combination. And then we have 4 choose 2. And then here we have 3 choose 3, 4 choose 1, and 5 choose 1. So now it's time to make sure that we go on our calculator and work these out one at a time nice and carefully. Again, in a stats exam, you do have to work pretty quickly to get all the answers here. So 3 choose 2 times 4 choose 3. That gives me 12 here. Okay, and I'll work out the other ones as well here. So you've got 2 boys, 2 girls, and 1 adult. That's 90. 2 boys, 1 girl, and 2 adults. That's 120. This one's not going to be much at all. 3 boys and 2 girls. That's going to be equal to 12. And then our last one here. So 3 boys, 1 girl, and 1 adult. That's equal to 20. Just making sure we've got everything correct in here. This one should be 6, sorry. So 3 boys and 2 girls, that's equal to 6. Once we've got those in our calculator, then we just add them all up together. So you have 210, 230, 242, 248. So that's 2,448 different ways, and that then gives us the 4 marks. Now, as soon as we see this same group of 12 people stand in a line, as soon as you get that idea of standing in a line and word arrangements, now we're going to go into a permutation question. Very important to identify, and that means order matters. And this is a pretty tricky question for part C. So we have how many different arrangements are there in which the 3 boys stand together, and an adult from our selection of 5 adults is at the end of each line. So if we draw this in, we've got 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. We have an adult, so let's just call that A1 and A2 at either end. And we've got the 3 boys standing together, so we've got B1, B2, and B3. Notice the boys are different people, so that's important. Again, we put a lasso around this to make this one big slot, and then we see how many slots we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we start with our 8 factorial. Now notice, and this is a tricky part compared to what we looked at earlier in the video, these boys are not the same. It's not like the candles from before. They can be identified slightly differently. So if we take B1, B2, and B3, how many different combinations of that do we have? Well, we could work it out on the calculator. We can also work it out here. So B1, so we've got B1, B2, B3. We have 3 boys in total. So how many different permutations can we have? We have B1, B3, B2. We have B2, B3, B1. You can see where I'm going with this. B2, B1, B3, B3, B1, B2, and then finally B3, B2, B1. So we have 6 different possibilities here. So we can times by 6, or this would also be the same as 3 factorial because we've got 3 slots here and we can move it around. Now we have to be really careful because we've got adults at the ends here, but order matters. So if I had the adult 1 here and adult 2 here, that would be 1 combination but 2 permutations, which is important. So if I've got 5 adults and I need to choose 2 to stand here, then I'm going to do 5P2. This is much more different than 5C2. So to work out my final answer, I have 8 factorial, and then we're going to do times it by 3 factorial, and then finally 5P2 to represent the different adults that can be at the ends of the line. Let's go to my calculator and work this out. So we have 8 shift factorial times 3 shift factorial. And now the P button, we haven't used this in the video so far. So we have 5, we go shift, we go to the times button, P2, and that then gives us a big number, 4,838,400. So 4,834,400. To write that number in correctly to get all 4 marks. So you can have a look through the mark scheme and see how we have worked these different things out. C is definitely a tricky question. If you're finding this topic challenging, then focusing on A and B will give you most of the marks for these kinds of questions. Okay, on to our next question here. Again, if you're liking the content, then please do like and subscribe. So now we've got a number of different possible arrangements, keyword arrangement here, of the word celestial. So we're looking at permutations, order matters. So again, I do my slots then. So 2, 3, 4, 5, 6, 8, 9. So we're going to have 9 factorial. And then we need to divide through by any repetitions. Well, we have 2 E's. It's worth writing down for later. We have 2 L's. And do we have anything else? Nope, that's it. So we divide by 2 factorial, 2 factorial. Again, you know how to do this on the calculator now. That will give you then 90,720 for the 1 mark. Now we've got the number of different arrangements of the 9 letters, in which the first letter is C, 5th is T, and last letter is E. So again, slot filling approach is the easiest way to do this. 5, 6, 7, 8, 9 First letter is C, fifth letter is T, and the last one is E. So we have 1, 2, 3, 4, 5, 6 slots. So 6 factorial. Do we have any repetitions within these particular slots? Well, E is not now repeated anymore, but we do have an L, so we do need to divide by 2 factorial for the L's, and that will then give us 360 arrangements for our 2 marks. Now this question is slightly different to previous questions. Notice we're looking for a probability, which is important, and a randomly chosen arrangement of the 9 letters in the word celestial does not have the 2 E's together. Now we know for any arrangement here, we know there are 90,720 ways. And again, the way that we approach this is we work out the 2 E's together. So I'm ignoring the not for the time being. So we have the 2 E's together here. Again, we've got our slots, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have the 2 E's randomly together. We put our lasso around those E's to make one particular slot. So now we have 1, 2, 3, 4, 5, 6, 7, 8 slots, 8 factorial. And then do we have any repetitions? Well, the E's are already accounted for, but we do have the L's. So that's going to be over 2 factorial. If you do that on the calculator, that's going to give you, actually let's do it on the calculator. So we have 8 factorial divided by 2 factorial. That gives us 20,160. So to work out the 2 E's not together, and we've seen this idea before, there we are. We've got a total amount of ways, so 90,720, minusing when the 2 E's are together, will then give us the E's not together. And if we take those away, we get 70,560. However, that's not the final answer because we want a probability. So the probability here will be equal to 70,560 divided by the total number of ways, 90,720. And this magically simplifies as what your calculator is there for, to give you 7/9 to give us our 4 marks. Now, as usual in these permutation combination questions, they'll do a mixture of both. So now we've got a selection. So we're now going into our combination style question, and we're selecting 5 letters from this word celestial. And we want a number of different selections if the 5 letters include at least 1 E, and at most, this is interesting, at most 1 L. So let's deal with where the E's and L's go, and then we can work out the other letters, so our C, our S, our T, our I, and our A, and how they go in. So we need all our combinations, so let's keep things consistent. So we'll start with E and some other letters that are not L. Then we can have E and L, so 1 E and L, and then 3 other random letters. Now we've got 2 E's in the question, so we could have 2 E's and then 3 random letters that are not L, or we could have 2 E's, 1 L, and then 2 random letters. Remember, at most 1 L, so we either have 0 L's or 1 L. So once we've done that, we've got how many letters remaining? So 1, 2, 3, 4, 5. So you've got 5 letters left that are not E and not L. So we need to then work out from the 5 letters left, 4 are missing, so 5 choose 4. Here we've got 5 choose 3. And here we've got 5 choose 3, and here 5 choose 2. So all we need to do is work out these binomial coefficients, which we can easily do on our calculator. So if I pop it on the calculator here, 5 choose 4, so that's equal to 5, and then 5 choose 3, that's equal to 10. So we have 5 here, 10 here, 10 here. This is also going to be 10 as well if you do that on your calculator. And if we add those selections together, we then get 35 selections, which gives us our 3 marks for this question. Key thing to realize is we focus on the E's and L's, and then we leave blanks for the letters that are not E or L, because we've considered those situations, and then we can work out the combinations from there. Okay, so you've got the mark scheme here that you can look through. And of course this section here, so we get 7/9 at the end, and then this part here as well. So we get the total of 35. If you want to catch up on all things paper 5 and make sure you're really ready for those exams when they come up, then check out the video in front of you, because I spend 2 hours going through everything you need to know to do really well on that paper 5.